Okay, so our first topic is to talk about what factors determine the type of igneous feature that you end up with. So if you've ever looked at volcanoes, you know that that volcanoes come in various shapes and various sizes. And so that is going to be caused by, one, viscosity. So viscosity is the resistance of a substance has to flow. So I want you to think about water and versus molasses. So water is very runny. So when you pour out some water, it comes out very easily. But on the other hand, maple syrup is going to be very viscous. It's not going to be runny. And so we're going to find out that if you have a magma which is very runny, then when it comes out onto the surface as lava, it's basically just going to run sideways and make a very thin layer on the Earth's surface. But on the other hand, if you have something that's very viscous, it's going to mound up when it comes out. Now this has to do with the atoms that are holding the magma together. So sometimes the magma is held together very strong, and sometimes it's not. So this is going to be viscosity. Okay, what's another thing that is going to be affecting the type of igneous feature that you end up with? It's going to be temperature. So you'll notice that if the temperature goes up, then the viscosity goes down. And so again, you can think about maple syrup. So if you have cold maple syrup and you pour it on your pancakes, it tends to be sticky and it tends to mound up. On the other hand, if you heat up your maple syrup, then it becomes more runny. So it becomes less viscous. So if you increase the temperature on your magma, then that's going to make it more runny. It's going to make it less viscous. Okay, it also depends on what's the composition of the magma. So one of the things is the amount of silica that is inside the magma. So you remember the silica tetrahedrons. The silica was in the middle, and then it has the 4 oxygens that are surrounding it, and we said that those silica tetrahedrons could be glued together into chains. Well, what happens when you glue them together into these chains and other complicated structures is that they tend to stick to each other, and then that increases the viscosity. So the higher the silica content, the more silica tetrahedrons that a magma has, the greater its stickiness is going to be, the greater its viscosity. Okay, but look at what volatiles do. So volatiles are going to be anything that has the capability of turning into a gas. So a good example of that would be water. Water is a volatile. If you heat it up, it turns into a gas. So what do gases do? Well, you can see that they decrease the viscosity, because what they're going to do is the more gas that you have in the magma, it's going to be holding those silica tetrahedrons and keeping them away from each other so that they can't hook up and increase the viscosity. So the more gas that you have in your magma, the less viscous that magma is going to be. And then a third thing that's going to affect the type of feature you have is going to be the outside pressure on it. And so the more pressure on a gas, the more likely it is that that magma is going to be explosive when it comes out of the volcano. So it depends on the pressure that the magma is under. Okay, so we'll take a break, and when we come back, we're going to talk about products of volcanism.